Good afternoon, the internet, and welcome back. We're still streaming live from reInvent. In this segment, we have a very interesting guest. We're going to talk about SageMaker, and SageMaker is actually the love product of Randall as well. So
this is my favorite service. I know I'm not supposed to play favorites, but this is my favorite service, and I am so excited to listen to the announcements that you have today.
Thank you.
So Urvashi, do you want to introduce yourself and tell us which team you work with?
Absolutely. Hello, everybody. My name is Urvashi Chaudhary. I'm a senior product manager with Amazon SageMaker, and this is a really exciting period for us because we have all these new announcements coming up, and I'm very excited to talk to you about how we're making pre-processing and deploying inference pipelines in SageMaker much more easier.
Right. And you said you're also part of the reinforcement learning launch, right?
Absolutely.
We're not going to talk about it now, but I'm
yes,
sure you've been super excited about that.
Absolutely. Now we do. Now you can do reinforcement learning on SageMaker as well. So if you're interested in building intelligent, autonomous applications, I highly recommend you check it out. We have tons of examples. You can get started right away.
So before we dive deep on what these new announcements are, can we take 3 or 4 steps up and just talk about what SageMaker is at a high level and how people use it, how customers use it?
Absolutely. So SageMaker is an end-to-end machine learning platform that makes it easy for developers and data scientists to build, train, and deploy machine learning models. So if you think about how machine learning has evolved, you have data scientists who are doing a lot of the science and algorithm implementations, and they're taking business problems and writing cool algorithms to do predictions or forecasting or classification type of problems. And you have developers that are trying to take these services or machine learning models and put them into production. And they're using very different tools, they have very different skill sets. So Amazon SageMaker is a great platform for bridging this gap because it's very simple for developers and data scientists to use the same set of tools and collaborate and easily build machine learning models, train them in a distributed, fully managed infrastructure, and then deploy them on auto-scaling endpoints for real-time or asynchronous batch needs.
I always say that SageMaker is the best way to get started with machine learning because it uses notebooks, which in my opinion are amazing. They are interactive documentations that you can just follow. You'll have a little demo about a notebook later, but this is for me like the best way to really get started. And then SageMaker comes with built-in algorithms, which are all documented in those notebooks, right?
And
absolutely.
I have the distinct pleasure of going out and talking to a ton of different customers all over the country, all over the world sometimes, and they keep telling me this one refrain, which is, well, we had a little bit of machine learning stuff already, and we were just able to use SageMaker to fill in every single gap. Because if you already have a notebook server, then you just use the other parts of SageMaker. Because the SDK, you just pip install SageMaker, you're done. If you already have a training service, you use the notebooks, or you use the hosting service. If you already have a hosting service, you use the training service and the notebooks. It's
3-in-1 service.
Yeah.
It's really 4-in-1 almost.
And
it's built in.
The best part is it's fully managed, so you're not spending time managing any infrastructure. You're only paying for what you're using, and we're constantly innovating and launching several new features that you've heard today already, and that brings me to some of the cool new things we're announcing. Sure. So we, in SageMaker, we already support TensorFlow, MXNet, PyTorch, and Chainer machine learning frameworks. And one of the most common requests that we get from customers is, when are you supporting scikit-learn? Because scikit-learn is a hugely popular machine learning framework, and it's very simple to use. There's a lot of demand for it. Just today, we had a lot of customers asking in the Twitch stream as well as in our booths. So I'm really excited to announce that we have a new scikit-learn framework in SageMaker that you could use. It's well integrated with our Python SDK, and it's really simple to use with lots of examples.
I just want to say, right before we got started here, somebody named Cuttlefish Riot in the Twitch chat was like, can you guys please launch a scikit-learn estimator?
Well, Cuttlefish Riot, so that's your answer right there.
It was just for you.
Yep.
So can you explain a little bit what scikit does and why is it very relevant for our customers, and what are we doing now about bringing it to SageMaker?
Absolutely. So scikit-learn is a very popular machine learning framework that you can use for a lot of the machine learning algorithms that are built in, like regression and classification, as well as it's very helpful for doing data transformations and pre-processing. So it's very simple scikit-learn, is very good for single instance where you have small data sets and you can run it from your notebook instance. But in many cases, customers have a large data set where it's not possible to pre-process it or manage it with a single instance. So that brings me to the next announcement that we have, which is we're also supporting Spark ML.
That's great.
And you can use SageMaker notebooks to connect to Glue or EMR and kick off your Spark ML jobs. And these could be transformations, these could be running ML pipelines, or this could also be running end-to-end machine learning with Spark ML.
So when you say SageMaker supports Scikit and Spark ML, that means we are building containers.
Correct.
Right, so can you explain how do we do this, or what does it mean?
So with the built-in containers, what we've done is we've taken the complexity of setting up a lot of the environments and dependencies and all the different libraries that you would need for running a specific framework or tool, and we've launched a container which is public, so all you need to do is bring your data and you can use the containers and the capabilities that are built in and just start using them.
People could do that before in SageMaker, but they had to write their own things, right? And now we take that away from them so they can just use our container.
So with scikit-learn, for example, you could very well do scikit-learn prior, but you had to kind of build your own container, and that was a little cumbersome, and for a lot of customers, they like the ease of SageMaker where everything is built out of the box, and you can just use the Python SDK and the estimators that are provided, and write one line of code and use it. So it's a great feature to have these kind of built in, and it really accelerates how quickly you can get started and move on.
And when you say one line of code, it's pretty much that. It's from SageMaker import MXNet, from SageMaker import PyTorch, from SageMaker import TensorFlow.
Absolutely.
And then you say TensorFlow.estimator, run on this many instances, do this thing, and just work.
And it works. And we'll continue to add more. We're always listening to customer feedback, so when customers tell us they want us to add a new framework or it serves a specific need, we listen. So we launched Chainer a couple of months back, and now these 2 new frameworks, and we'll continue to work on them.
So how do you write code for doing pre-processing with these 2 containers?
Great question. So any machine learning practitioner, data scientist, developer will tell you that they spend a lot of time pre-processing their data.
Yeah. It's where you spend most of the time,
It's where you spend most of the time, and that's where scikit-learn and Spark ML are really popular tools to use and frameworks to use, because they have a lot of built-in transformers that you can use, and feature processors, and different capabilities that you can use individually, or you can chain them together in a pipeline, and you can execute a series of steps that you want, or a series of transformations.
So what kind of pre-processing is usually done for machine learning? I mean, one-hot encoding is one of them, but
absolutely.
What are the popular ones?
There's several, so one-hot encoding, string indexer, vector assemblers. There's many different types of normalizations, feature engineering type transformers you can use.
In images, for instance, you resize them for 224 by 224 for at ResNet, or you go and say like, hey, I want to mean the images, so you take the entire data set of images and you're like, I want to do a color mean across all of these so that I don't have these weird outstanding features. I did that for all my selfies. It didn't help.
and you'll see, a lot of times the data that you're getting, so let's say you want to do a classification problem, or you want to do a regression where you're predicting something, your data may be coming in strings or text or a mixture of different formats, and in order to train machine learning models, you typically have to provide data in a specific format. So one of the advantages of the new frameworks that we've launched is that you can use scikit-learn or Spark ML to do your data transformations, and then pass that data to your machine learning algorithm for training or for inference.
Right, and let's actually deep dive on that, because a lot of people think pre-processing is mostly for training, but actually pre-processing is used as well for inferences, which is predictions, right?
Yes, so let's say, for example, you want to predict, or you've trained your data to, your models to take input in a certain format, and you pre-process it, and now for XGBoost you need data which is in numerical format.
Yes.
But now when you do your real-time predictions, your data that's coming is in strings, and it's not really in the format that your XGBoost algorithm container can implement. So your choices until now were you either do it outside of SageMaker or in your client applications where you pre-process it and send it in numerical format, or you build it in your inference container where, as part of the inference process, you also pre-process this data.
And this was a problem, right?
This was a challenge because the big challenge that we heard from customers was that when you have pre-processing that you do for training, and you have separate workflow for pre-processing and inference, a lot of times these can get out of sync.
Yeah.
So
configuration drift.
Absolutely, and you're iterating so quickly on your machine learning models, and you're iterating so fast on your client applications that if your pre-processing is not matching, what's going to happen is when you do your prediction, you'll get an unexpected outcome, and then debugging is difficult. It's extra management on the developer or data scientist part to kind of manage these two different steps and really figure out what's going wrong and where. So the next announcement that I'm very excited to talk about that we've made is you can deploy inference pipelines in SageMaker.
Exactly. And that's a big deal.
It is a huge deal because what it essentially allows you to do is you can write your pre-processing code once, and you could use scikit-learn or you could use SparkML, and you can essentially package that together, bundle it,
and boom to the inference.
Push it onto S3, and we have serving containers for both scikit-learn as well as SparkML, and you can now chain multiple containers on an endpoint. Right. So essentially where you could previously just pass your data and do a single step at inference, and everything had to be packaged together, you can now break that out and do up to 5 steps that happen sequentially. And you can define what those steps are.
So let me kind of break that down and restate it briefly and make sure that I understand it correctly, because I only learned about the feature today, and I'm super excited to go and play around with it. If I have my data in a particular format, and I want to do some pre-processing step on it for training, I define that once in one container. And I can say this pre-processing script, again, I'm going to be getting data from my API endpoints for my inferences in that same step. So I can use that same container to do the processing for the inference, the pre-processing. And then if I wanted to do pre-processing for one of the built-in algorithms, for instance, I could put one of these containers in front.
Absolutely.
And it would just go boom, 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 boom down the line.
Yes, and it doesn't have to be, and it doesn't have to be just the built-in algorithms that we support. You could take your pre-processing code, which is Scikit, Spark, or your own pre-processing code,
and it would auto
in your own container.
Yeah,
you can do for inference, you can use one of the SageMaker algorithm containers or the framework containers like TensorFlow and MXNet, or you could bring your own containers. If you've done some magic on your end and you have your own inference container, you can bring that in, and you can have an optional post-processing step and have up to 5 steps where you could just pass the raw data and we take care of everything. And the best part is that if you make changes to your pre-processing step for training, you'd have to make no change because it passes through to your inference pipeline as well.
That's going to be making the pipeline a lot cleaner, right?
Absolutely.
So
it's so much easier to manage,
no code there, and all that
so
stuff.
modular, and it really makes life simple. And you don't have to pay for multiple endpoints because all these containers get deployed onto the same instance, so you're not standing up 5 different endpoints for deployment or 5 different batch transforms for batch. You are essentially putting them all on the same instance, and your request executes through them. So it's a lot of cost saving.
Show us the code.
Oh, yes, let's get to it.
I'm sure the audience wants to see, at least I know I want to see. So can we show the computer? All right, so where are we?
So we have several examples in SageMaker examples that you can simply clone and get started. So the one that I'm looking at is we're doing feature processing with SparkML, and then we're training with XGBoost, and then we're deploying these as an inference pipeline. So I'm going to get to the key parts. So here I've defined my PySpark script, and essentially I have 3 transformers that I'm applying as part of my ML pipeline. So I take my raw data, and I apply a string indexer, I apply a one-hot encoder, and I have a vector assembler. And
one-hot encoder is transforming numbers into 0 and 1s,
yes.
Right? This is a very common step for machine learning.
These are very common steps for machine learning, and there's really good documentation. So here I've opened up the Spark documentation, and you can see there's a long list of transformers here that you could use. So in our pre-processing right now, we've identified these 3 steps, and we create a pipeline here which takes your string indexer, your one-hot encoder, and your assembler, and then you do a pipeline.fit, which essentially trains your data here, which means that you're passing your input data and it's transforming it to go through all of these steps and give you numerical data at the end of this.
Right.
And using the serializer here, so we're using Spark MLeap here to serialize. This is a step where essentially this code that you've written, this ML pipeline, you export it and you push it on S3 that you can then use with a Spark ML serving container that we've launched. And I'll walk through what that is, but essentially this is your pre-processing code, and this is what executes for both training as well as for inference.
It's always shocking to see so few lines of code.
Absolutely.
Back in the days, it was like literally hundreds of lines of code to do all that. Yeah.
And we have a tenant where we want you to be able to bring in your 20 lines of Python code and be able to run it in SageMaker. Okay, so here what we've done is we've used Glue, which is a serverless and fully managed Spark environment. And essentially we pass this script that we have. So I'm going to move down here, but we use Glue here, and we pass the script along with the location of the input data that we have, and Glue executes the Spark transformation for us.
And it can execute it on EMR, right? For example.
Yes, and if you have your own EMR cluster, you could kick off the same job and do this processing on EMR.
This is very common, right? So use EMR to do this kind of things.
Absolutely. The advantage with Glue is that you don't have to manage your cluster. So when I start this job here, that's when my cluster gets set up, and when this job completes, the cluster gets, it goes away. So I'm only paying for what I'm using, and I can go to my Glue console here, and I think I got logged out. But you can see all your jobs, you can find them back in Glue. So essentially now I've pre-processed my data for training, and then I pass that to XGBoost, and I do my training for XGBoost. And so here you can see that I'm doing my fit, and within 42 seconds, I have trained model. And now we want to create the endpoints for real-time hosting, or if you have data coming in batches, you want to run the same 2 steps. So essentially what you do is you'd be able to pass here. So in this pipeline model, you can see now that you're able to pass a list of models. And here the Spark ML model is essentially your pre-processing step, and the second step is your XGBoost step. And the same model that you create can be used for real-time inferences, or you can use it for a batch transform.
And it's not like you're defining separate endpoints for each one. It's all one endpoint,
It is all one endpoint. And if I go to SageMaker, let me see if this will be quick enough. Great. And this is a previous job that I've run. You can see here that for the same model,
it's got container
I have
one
container
and
one,
container 2.
and here, I use scikit-learn.
That's awesome.
And this is the container that we've launched. This is where your data is, or your model artifacts are. And then your container 2, here you're using linear learner, and then your model artifacts.
It looks almost too simple.
It is quite simple, and you can use the examples and try it out, and give us feedback and let us know how you're using this feature.
So my last question is actually, how do people get started now? If they're on the stream and they say, okay, I want to try that, what is your suggestion?
Well, I would say the best way to get started is to try it yourself. And we have examples in the SageMaker
so this
notebook
is
where,
now on SageMaker.
Yes, these examples are on SageMaker. So if you open your Jupyter notebook, you can see several examples.
Awesome.
And if you go to advanced functionality as well as the Python SDK, so here you can see the scikit-learn estimator example. You have the inference pipeline example. So just clone these examples and get started.
Thank you very much for joining us and explaining how everything works.
Thank you.
And thanks, Randall. And thank you, Internet. And we'll be back soon.
Thank you all.
See you soon.
Bye-bye.
More announcements.